Hey, what's up, guys? Today we get to learn about absolute value equations for the first section of this half chapter. Um, and we're actually doing the whole section today, so it's going to be nice and short. It's a pretty easy one. And it's on solving absolute value equations. So to do that, what you need to remember about absolute value is the absolute value represents the distance the number is from zero on a number line. So when you solve equations with absolute values, there's typically going to be two solutions because there are two numbers that have the same distance from zero on a number line. So for instance, 7 and -7, they both have an absolute value of 7 because they are 7 spots away from zero on a number line. So to solve an absolute value equation, what you're going to do is you're going to isolate the absolute value, and then you're going to set that equation, dropping the absolute value, equal to the positive version and the negative version. So my first four examples here, the absolute value is already going to be isolated. So if I look at this one, the absolute value is by itself on its own side of the equation. So I write two separate equations, one that's equal to the positive version and one that's equal to the negative version. So since I have p equals 7 and p equals -7, that one's already solved. There was nothing to do. On 2, maybe this will make a little difference. Notice I've got the absolute value already isolated. It's on its own side of the equation by itself. So I would have 5w plus 3 equals 7, and 5w plus 3 equals -7. So we set it equal to the positive version and the negative version. And then we solve both of those equations like we've been solving forever and ever. So the first thing we do is subtract 3 from both sides of the equation. You would be left with 5w equals 4. And then you would divide both sides by 5. And 4 isn't divisible by 5 evenly, so you just leave it as the fraction 4/5. So there's your first solution. The second solution will follow the same steps. We would subtract 3. 5w equals -10. And then again, divide by 5. And -10 divided by 5 is -2. So you get 4/5 and -2 for your solutions. Remember, you can plug these back in and see if they work. Number 3, we'll do that one together again. First fraction one. So again, the absolute value is already isolated. So it's going to be x over 2 minus 1 equals positive 11. And x over 2 minus 1 equals -11. Okay, now there is a fraction in this problem, so my first step would probably be to get rid of it by multiplying by the denominator of 2. So 2 divided by 2 is 1. 1 times x is still x. 2 times 1 is 2. And 2 times 11 is 22. So that's nice and easy to solve. You just have to add 2 to both sides. It looks like x equals 24 for our first solution. On the second one, again, same steps. First, you're going to take the whole equation and multiply it by 2. So 2 divided by 2 is 1. 1 times x is x. 2 times 1 is 2. And 2 times 11 is 22. Again, just one more thing to do. We got to add 2 to both sides of the equation. And x equals -20. Okay, so here is where some students will make mistakes. They'll solve the first equation and they'll get 24. So they'll say, oh, the second one must be -24. Well, notice that's not the case here. So you always have to solve both of those equations separately because you'll see the solutions are never just opposites except for on very simple cases like number 1 is. So if you want to pause the video here and try number 4, that would be awesome. Okay, so let's see how you did there. So first, the absolute value is already isolated. So it's going to be 2x minus 3 equals 5, and 2x minus 3 equals -5. Okay, let's solve that first equation. Add 3 to both sides of the equation, and 2x equals 8. Divide by 2, and x is clearly 4. On the second one here, add 3 once again. 2x equals -3 plus -5 plus 3 is -2. Divide by 2, and x is -1. So you can comment below, tell me how you did on that problem. That would be awesome, that's the YouTube thing to say, right? All right. Okay, so here's your hint. If the equation x with absolute value is not isolated, make sure to isolate the absolute value expression first. Here's where most mistakes will actually be made. You'll forget to isolate the radical before, or the absolute value before you write your two equations. So you have to isolate the absolute value first. So maybe even write it down to remind yourself. Isolate absolute value first. Write that down. Isolate absolute value first. So what does that mean? Notice, look at number 5. The absolute value is not by itself on the left side of the equation. There's a 5 on the same side of the equation. So we have to get rid of that 5 first. We subtract 5, and now you'll see the absolute value is by itself on the left side of the equation. So now we're ready to write our two equations. The first one would be 2x equals 2. The second one, 2x equals negative 2. Both of those are very easy to solve. You just have to divide by 2. X equals 1. X equals negative 2. I'm sorry. X equals negative 1. Now again, just because the first equation is 1 doesn't always mean the second equation is going to be negative 1. These are just very simple examples, and that's why it's working out that way. Number 6, is the absolute value symbol isolated? No, there's an 8 on the same side of the equation as it. So first you must subtract 8. So that gives us the absolute value of 3x equals 6. So that means 3x would equal 6, and 3x would equal negative 6. Divide by 3, and x equals 2. Divide by 3, and x equals negative 2. So again, we got the opposites, but that's just because these are very simple examples. So don't just assume they're negatives. Okay. The next two examples are going to illustrate a special case for absolute value equations. This special case occurs when an isolated absolute value is equal to a negative number. Okay, so number 7, is the absolute value symbol isolated? No, there's lots of things that need to happen before we are able to write our two equations. So first you would subtract 25. So 2 times the absolute value of x equals 23 minus 25 is negative 2. Next, you would divide both sides by 2. And you would have the absolute value of x equals negative 1. Okay, so you have to think about absolute value. Can the absolute value be negative? Remember, what does absolute value mean? It means the distance from 0. Can you have a negative distance? No, you can't go negative 1 miles. You can just go 1 mile, right? Even if you walk backwards or something, EJAWS. So if you ever have an absolute value isolated equal to a negative number, it is no real solution. So maybe make a note. Isolated, sorry, you can't see that. Isolated absolute value can't be equal to negative number. Look at that, 2 notes today. So look at 8. Absolute value is already isolated. It's equal to a negative number. Bad. No real solution. Okay, so keep your eye out for that. All right, and then the last type of problem that you're going to see is 2 absolute values on both sides. So it's similar to the other ones. The only difference is you're going to distribute a negative on the second equation. So the first one, the first equation, it's going to look exact same. You're just dropping the absolute value symbols. The second one is going to be, you're going to have to put the second part of the equation in parentheses and put a negative on the outside. So we have to distribute that negative. So let's solve that one on the left first. So remember, if there's variables on both sides of the equation, I like to move the one that's smaller. So which one's smaller, 3x or 5x? Well, 3x is smaller. So you'd subtract 3x from both sides of the equation, and you'd be left with that would be 2x minus 8. I like to have the equal over here, so equals 2. You good with that? I moved the 2 over to the other side of the equation. Next, you would add 8. 2x equals 10. And then, of course, x is 5. Okay. Let's look at that second equation. Solve it. First, you would distribute that negative. So I would have 3x plus 2 equals negative 5x plus 8, right? Okay, now the same as before. Which one's smaller, 3x or negative 5x? Well, negative 5x is smaller, so we would add 5x to both sides of the equation. So I would have 8x plus 2 equals 8. And then we're almost there. Subtract 2. And 8x equals 6. Divide by 8 to both sides of the equation. And does 8 go into 6? No. But does it reduce? Yes. Those are both divisible by 2. So it would reduce to 3/4. So we get 5 and 3/4. Awesome. Let's look at number 10 together. So again, we have absolute values on both sides of the equation. So our first equation is going to look the exact same. Just drop the absolute value symbols. My second equation, we have to put the second part in a parenthesis and distribute a negative. Okay, so notice, second one goes in a parenthesis. We put a negative on the outside of that. Okay, let's solve these equations. Okay, which one's smaller, positive 1x or negative 1x? Well, negative 1 is smaller, so we would add x to both sides of the equation. Remember, 1x plus 1x is 2x. 2x minus 3 equals 5. We're almost there. Next, you would add 3 to both sides of the equation. 2x equals 8. Divide by 2 and x is 4. Okay, second one. Start by distributing that negative. So we would have x minus 3 equals negative 5 plus x. Okay, which one's smaller? X or x? Well, they're the same, so you just move either of them. How do you get rid of a positive x? You subtract x. Those cancel and those cancel, and we're left with negative 3 equals negative 5. Now that is not true. Negative 3 does not equal negative 5, so this one doesn't produce an answer, but we did get one answer from the first one, so x would be 4. You just get one answer that time, and that happens. Okay, if you want to pause the video here and try number 11, that would be awesome. Try it. Go. All right, let's see how you did. Let's put those two equations. First one, just drop the absolute value symbols. Second one, the second part gets put in a parenthesis with a negative on the outside. All right, which one's smaller, 2x or 3x? Well, 2x is smaller, so we subtract 2x from both sides of the equation. So I have 4 equals 3x minus 2x is 1x, or just x minus 1. Okay, I like my variable to be on the left side, so I'm going to say x minus 1 equals 4. And just one more step to solve that. We add 1 to both sides of the equation, and x would be 5. Okay, let's look at that second equation. Start by distributing that negative through. So I would still have 2x plus 4 equals negative 3x plus 1. Okay, which one's smaller? 2x or negative 3x? Clearly negative 3x is smaller, so plus 3x. And then 2x plus 3x is 5x, plus 4 equals 1. Just a couple more steps here. Next, you would subtract 4. 5x equals negative 3. Divide by 5, and 5 doesn't go into it evenly, and the fraction doesn't reduce, so it would just be negative 3/5. So there's your two solutions for that equation. So don't forget all of the things we talked about today. If you need to, go back and rewatch the video, whatever you need to do. Good luck on the My Math Lab assignment. We'll talk to you later. Have a great day, y'all.